All right, we're set.
Then you said one thing and then you were done.
Yeah,
So-
it was the last line.
All right, have your notes read. Well, have your sheet ready. People in the back. Tune in. X equals negative y to the squared plus 4. X equals y plus 2. Y equals 0, y equals 1. Does anybody remember a sneaky trick to doing this problem? Ahem. This is going to be revolved about the x-axis. You may notice the top is a sideways parabola. And this thing is a line that's in a weird form. Is everybody tuned in? Everybody. There is a trick if you find the sideways ones difficult. It is a good idea to know how to graph these, the sideways ones. They're not that bad, but there's an optional way. Let me know what it is.
Switch the X and Y.
Switch all the x's and y's. Basically take the inverse of everything. Y equals negative x squared plus 4. Y equals x plus 2. X equals 0. X equals 1. And be careful. Revolve about the y-axis. So all the x's become y's and all the y's become x's, including the axis you're spinning around. So if you want to do that, you're welcome to. Question, did anybody want to just do it the normal way, or you want to see it that way? They'll both give you the same answer. And by the way, this is a legitimate way to do it on the test, if you want to do that. Preference? I don't care. All right, I will do it this way, just because it's easier for people to picture this. This is a parabola that's upside down with a, it's been moved 4 spaces up. Normal height multiplier, so over 1, down 1, over 2, down 4. Whoops. And then this is y equals x plus 2, which is here. And x equals 0, which is here. Let's make it a little darker. And x equals 1, which is here. Now, which region are we talking about? There are lots of little regions in here. Let me run this thing up. It's got to be between the parabola and the original diagonal. We're looking at this. Does that make sense visually? Now, in order, we're spinning this around the y-axis now. So I'd like to use shells, but why can't I not use shells right away? Like if I just pick a dot here and spin it, what's wrong with just using shells from there and just finishing the problem? Oh, math people. Oh, Pete. What's wrong with using a shell here, just one step and do the problem? What do shells do?
They take like the area of like the whole thing.
Kind of, sort of. Like, how do you get the height? Like, where does the height go to?
It goes to 4.
It does go to 4. What's the bottom?
The bottom. Like 0.
0. You see the problem? If you actually sent a shell down now, oops, wrong thing. It would go too far. I want just this little thing here spun. It'll kind of look like a, I don't even know what it looks like. It looks like a gumdrop that's it comes to a point. But I don't want this bottom spot. That's going to be empty. Is there a way to do that? Julie, let's see, Sean. Right. Subtract, in other words, do the parabola shells minus the thing below shells. In other words, if you take this parabola thing and do the stuff underneath, and then take this trapezoid thing and do the underneath, spin them both and subtract. That should work. Let's see how this works. If you're doing, if you don't know this is okay, but let's try it. Michael, what's the volume of a shell?
Equals 2 pi r ht.
Correct. 2 pi r h t. I'm going to do that here. So it's that's one shell. To get all the shells together, you have to use what, Max?
The
Integral. So you're going to do the integral of 2 pi r h t minus another integral of 2 pi r h t. The only difference is going to be, this is going to be the first radius height thickness, this is going to be the second radius height thickness. Let's fill these in. You see why we're subtracting, by the way? If you take the entire volume and then subtract the volume of the lower thing, you're left with the volume of the higher thing. That's what we're doing. So, take over, Jana. I'm going to pull the 2 pi out in front. But the integral of something, something, something. Which one do you start with? It's one integral minus another integral. What's the first integral?
Like the larger.
Yeah, so which one would that be?
The,
From?
first equation.
Yeah, the first one, the parabola one. So let's take a look at that parabola one. If you do a shell from here, what's the radius? Is it x, y, dx, or dy?
X,
It's x. What about the height?
Y,
Y. And then what about the thickness?
dx.
Dx. Let me see why those are as they are. Because whenever you have a shell, look and see which direction the thickness is going. This is dx. I'm going to call this y1. So you know which one it is. And Julie Miller. Minus, I'll do 2 pi in front. Something, something, something. We're going to do the, instead of below the parabola, we're doing below the line. So what's the radius if I did the shell from here? Is it x, y, dx, or dy? X, because it's going sideways. What's the height? Y. What's the thickness?
dx.
Correct. dx, because it's running this way. Now, this is going to be y2. Can I just take the integral right now? No, what's wrong? Right, all the variables have to agree, and it looks like the easiest way to do it is replace the y's. So, no, take over. What's this going to become? 2 pi times what? The integral of?
So, you can substitute negative x squared plus 4 for y1.
Yeah, so do x times negative x squared plus 4 dx. Does that make sense? I would strongly advise you not leave it like that, because this is relatively easy to simplify. It's a lot, you'd have to kind of like do a substitution problem here. If people think, wow, is it chain rule? As long as you distribute, you don't have to do that mess. Plus 4x, parentheses, dx. Does that make sense? Just make it easier to plug into the calculator and to do it by hand if you had to. Minus 2 pi, what's the other one? No, go ahead. What would I put here?
Yeah, so then you could do, want me to substitute it? X squared plus 2x.
Oh, yes. Yeah, x parentheses x plus 2. Yeah, dx. So I'm going to I should have done that up here, sorry. X plus 2 dx. Yeah, let me do it like you did. This is going to be x squared plus 2x dx. Question, Pete. From what to what?
So it
I
would
drew a bunch of junk. Are we using X's or Y's?
X's.
X's. So what range? From what?
0 to 1.
Yes, from 0 to 1. It doesn't go all the way to 2 because we're not using that portion. So both of these integrals go from 0 to 1. If you want to make this easier, then again, this is optional. You can do them separately. I would pull the 2 pi out in front in the entire thing. But remember, when you have an integral of a plus b, it's the same as the integral of a plus the integral of b. Remember that? You can do that with derivatives, integrals, and limits. Any calculus function you can split up over addition. Look over here. Take a look. Optional, but everybody tune in. You can combine these back. You could do this. 2 pi times the integral from 0 to 1. I'm going to put these together. Parentheses, negative x cubed plus 4x, close parentheses, minus parentheses, x squared plus 2x. And this is all dx. Go ahead and write that. Everybody write that down. On your worksheet or in your notes, whichever you like. The reason I did this, do you have to do it glomming all together like this? No. You could do 2 separate integrals. It's going to take longer. Can anybody simplify this? It's going to be 2 pi times the integral from 0 to 1 of what? Can you make it just 1 parentheses? Just combining the like terms easily. You will have to distribute the negative though, beware. So, John, take over. What's the first term you have?
Negative x to the third
Yep. And then what?
plus 4x.
Do them in order though.
Oh, sorry. Minus x squared.
Yes. And this is going to be minus 2x
So plus 2x.
plus 2x. That is by far the easiest to plug in and the easiest to do by hand if you have to. I want an exact answer. You are welcome to use a calculator. However, how do you do that? If you if you do this straight away and you try to convert to fraction, it won't work. You're going to have a horrible decimal. Tell me how to do this. What do I type? How do I keep it from going irrational? Yeah,
I'm sorry, I'm confused.
go ahead.
Did you just subtract the 2x and the 4x up top?
Well, this, I distributed the negative.
Okay.
This is negative x cubed. I didn't do anything with that. This is plus 4x minus 2x.
Okay, fine.
That'd be plus 2x. And this just stayed the same.
Okay, great.
Okay. If you did the integral right now, you'd get a decimal. I don't want a decimal. I will take off major points if you do a decimal on it, unless I specifically tell you to round off. And this one, I want an exact answer. How? Go.
Could you plug the integral in, but not plug the 2 pi in, and wait until the end to
Correct.
plug that in?
Hold off at least on the pi, and the 2 pi, sure. But the main thing is, don't put pi in. You can put the 2 in, I don't care. But I'm just going to hold the 2 pi off. Do this for me. Go ahead and type this in. So math 9. I have negative x cubed minus x squared plus 2x, comma, x, I'm doing the old-fashioned one, comma, 0, comma, 1, close parentheses. What do you get? What do you get on screen? Can we get it? What decimal did you get? You have calculator? Okay. Yeah, get practice typing this in.
Mine never works. Mine takes forever to load.
So type this in without the 2 pi. And go from 0 to 1. What'd you get? You should have a repeating decimal. Have we got it? Yeah.
It's like 4.166666.
0.41666666? Yes, convert to fraction. What do you get? What is it? 5/12. So what you're getting is 2 pi times 5/12. Simplify that for me and you're done. Michael.
10 pi.
10 pi/12, which reduces to? 5 pi over 6, which is our answer. That make sense? Again, do you have to do this switcheroo thing? No. It is a little easier on our imaginations because you have a harder time graphing sideways functions. Functions that, like with y as the main variable. Big function. This is a function of x. This is a function of y, which is kind of weird. Zebra number 5. Number 6. Let's see what happens. Number 6, it turns out you didn't have to do a subtraction. All you had to do is set it up correctly. You can also do the switcheroo if you'd like. That's actually what I did. So we've got y equals x cubed. And I want to flip the other two. Y equals 0, y equals 1. Stay tuned in. And I rotate about the y-axis instead of the x-axis. So it looks like this. X cubed. Let's assume I just drop this. Yeah, question.
You have the y's and x's up there.
Oh, did I?
and messed up.
Oops. Oh, x is 0 and y is 1. So it's supposed to be y equals 0 and x is 1.
X equals Y.
Well, he just.
Which one?
Are you?
It's fine.
I'm flipping.
Oh.
Yeah. For number 6, I'm just swapping all the x's and all the y's. And it was going to rotate around the x-axis, now I'm rotating around the y-axis. You don't have to do this. Otherwise, you'll have to graph it sideways, which is not impossible. So, let me graph this. Y equals x cubed. What does that look like? That was actually a parent graph from pre-calc. True, it is a swerve, because it's got a triple root. A triple root where? At x equals what? Pretend you're solving this, like set it equal to 0. Like x cubed equals 0. What's the only solution it has? 0. There's a triple root at x equals 0. So it's going to come up, flatten up, and go like this. Over 1, down 1. Over 1, up 1. Over 2, up 8. We're not going to need that, but that's what this thing looks like. Go down to negative 8. Don't unplug. Y equals 0. Where's that? Do the station. It's what?
It's the x-axis.
It's x-axis. John, take over. X equals 1. Where do I find it?
Go to the y-axis and you go over 1.
To the which?
To the y-axis and you go over 1 and drop a vertical line.
Vertical line, correct.
Like,
On the x-axis. So you see the region we're talking about is this? The teeny little region there? You don't have to do any subtraction because when you're doing shells and we're rotating around the y-axis, the only trick we ever have to subtract from is if, because shells always fall to the floor, it's totally fine if you do that here. Here's the phantom part. I'm going to enlarge this. It's going to kind of look like this. And if if you take any point and drop a shell, that's going to capture exactly what you want. So, what's the volume of a shell, Max? 2 pi RHT, correct. And I'm going to ask 2 times pi times something times something times something. In this particular case, here's what you're spinning. What's R? X, Y, dx, or dy? Yeah.
It would be X,
It's x, correct. What's the height?
Y,
Y. What is the thickness?
dx.
Dx, because it's in the dx direction, correct. Can we take the integral right now? No, something wrong. Julie Miller, take over. What's wrong with this?
How the x's and y's.
Yeah, how do you fix that?
You would just make y x cubed, x cubed,
Correct. Replace this with x cubed. So what is this really?
x to the fourth.
Right. Please do that. 2 pi x to the 4th dx. It wasn't last year, but it was one of the previous years. Almost everybody in the class, I think it was even in my previous school too, they left it as x times x cubed. And they thought, wow, we have to do a substitution where u equals x cubed, and they're trying to get d. Whoa. Just combine them, you're fine. It's way, way easier. So 2 pi x to the 4th dx, the total volume is the integral. Pull the 2 pi up in front. Pete, from what to what?
It would be from
0 to 1. Are you using x's or y's?
0 to 1.
X's, correct. In this case, it's kind of ironic because x and y, the y's go from 0 to 1 also, but we're using x's. From 0 to 1 of x to the 4th dx. I would like you to do this by hand. Everybody in this room should be able to do this by hand relatively easily. So 2 pi. Somebody tell me the antiderivative of x to the 4th. Michael.
Sorry.
I do an antiderivative,
You add a number to the exponent.
and then what? So you raise the power and then,
1/5 x to the 5th.
yeah, and then divide by the new power. So 1/5 x to the 5th. Do I need a plus c?
No.
No, why not?
Because
It's about a month ago we covered this. If you take an integral with bounds, what's going to happen? The plus c is in there.
doesn't it just cancel?
Yeah, it's going to be blah, 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 minus blah, blah, blah. It'll be c minus c and cancel. Max, take over. Simplify this thing. What would you do to make this look easier?
Put in 0.
Yeah, but something first.
Well,
Pull out the 1/5. What is that in front now?
2 pi or 5.
Right. And then what's the antiderivative plugged in?
Well, we plug in 0, cancels to the 0.
Right, what do you plug in first?
To
The 1. So
Yeah.
1 to the 5th minus 0 to the 5th, which is just what?
1. 1.
Yeah. So what's your final answer?
2 pi or 5.
Got it. Does that make sense? Do you think you could do that if I threw it on a test? You are entitled to switch all the x's and y's if you think it's going to make an easier answer. Okay. Number 5 and number 6, we're going sideways, so that's not a bad idea. It is a good thing to be able to graph them sideways, but if you get stuck, it's better to get the problem than otherwise. Any other questions? All right, take out your notes, please. I would like to talk about one last rotational topic. There are 3 more topics in this chapter, and then the chapter test is coming. We have covered, here's a quick summary of chapter 6 so far. area between curves.
He's so full of wisdom.
Rotational volume. Which involves disks
He's definitely solvable.
and shells. And then the third, glass is still going on. And then the third thing we just touched on today, we're going to touch on today, is rotating around, please stop talking. A non-common axis. In other words, we've been rotating around the x-axis and the y-axis all the time. What happens when you don't? What happens when you try and rotate around a line? It can be horizontal, vertical, but somewhere else. What happens? For example, let's say we have y equals radical x. Let's make it nice and easy. And I'm going to restrict it from 0 to 4. And I want to revolve about the y-axis. I also want to use the equations x equals 0, x equals 4, y equals 0. This whole thing will give you what I would call region A. We're going to take region A and revolve it around the y-axis. So your very first chore is to graph this thing and find out what the region looks like. And I'm deliberately going to throw a curveball at you. You see the y-axis? Scratch it out. Not too heavily so you can see what's behind it. And I want to replace it with x equals -2. It's a brand new line we're spinning around. Y equals radical x. We've done that a lot of times. Over 1, up, it starts at 0, 0, over 1, up 1, over 4, up 2. There should be a line at x equals 4, a line at x equals 0, a line at y equals 0. Does everybody see that this is going to be the region? We're spinning that not around the y-axis anymore. We were going to. But around the line x equals -2. Does everybody see that when you spin it like that, you're going to get a mirror image over here? The graph started 2 spaces away, so it's going to start 2 spaces away. I need to go a little further. And then it'll go 4 spaces even further. Over 1, up 1, over 2, up 4. Here's the mirror image. Do we see visually what's happening? It's the same sort of setup, but we're not spinning around the y-axis anymore. This is going to throw off everything. You remember there are only 4 things that, when you do 2 pi RHT, the r, the h, and the t have to be either x, y, dx, or dy. Not anymore. This thing will mess it up. If I try a shell here, it'll look like this. It'll drop just like normal, and it looks like normal. But look at the radius. This is the y-axis, this is the x-axis. The radius is not x anymore. X would be this. This is more than x. Everything's getting thrown off. This could be a serious problem. Fortunately, there's a very sneaky cure for it. The only things we know how to rotate around are the x-axis and y-axis, ever. That is still the case. They're saying, rotate it around x equals -2, and I, and you, and we are going to stage a rebellion. Last week. We're going to point to this thing and saying, no, we refuse to be oppressed. We refuse to rotate around something weird. It's a violation of our constitutional rights, thank you very much. Bye. Now we still have to solve the problem. Watch what we're gonna do. This thing is too far to the left. Let's fix it. I want to move the entire graph to where it's supposed to be. How far do I have to move it? Two. Which way? To the right. Oh, people who remember your pre-calc. How do you move a graph 2 spaces to the right? -2 on the input. What does that look like? This whole mess, you're going to take the input -2. Basically, that's going to be take x and subtract 2. Wherever you see an x, subtract 2. Show me what this is. Do you see?
Y equals radical x minus 2.
Yes. What's this going to be? Max. Look at the graph rather than the, this is what you do with the formula. This moves the graph 2 spaces to the right. Basically I'm moving everything 2 spaces to the right. If you can do it by hand, great. If you can do it with inputs, great. The interval is not the same.
You just add 2.
It's from what to what?
2 to 6.
Exactly. You see what we just did? We're moving everything 2 spaces to the right. What about this? Keep going. This becomes what? 2. What's the other one? 6. What does this become?
Oh, negative 2. I don't know.
What's that?
I don't know.
Take this, this is the line y equals 0. Every look where my arm is. Pretend my arm goes forever, in both ways. I'm gonna move it 2 spaces to the right. What just happened? Nothing. In other words, you take all the x's and move it 2 to the right. You don't have to change the y's. It's y equals 0. Make sense? And you're going to revolve around what? We were revolving around x equals -2. Pete, what is it now? X equals 0. Is there another name for that? That's the y-axis. We now have a normal problem. Let's do it. I'm going to redraw it. Do you have to redraw it? No, but it actually helps reassure people. The graph starts 2 spaces to the right. And it's going to go to 6. Over 1, up 1, over 2, up 4. The lines go here, here, here. Here's the region. Oops. And here's -2, 3, 4, 5, -6. Here's the phantom version over here, here. Can anybody see this, what's going on? We're spinning it around the y-axis now. Would you use disks or shells, Michael?
Shell.
Why? Why not disks?
So you're gonna fall through.
Dang it.
You're gonna fall through.
I did, I don't know, what do you mean?
This, like it has to be revolved over.
Right, if you use disks, like here's what a disk would look like. And you ran that all the way, what would you get? what volume would you get? X. If you did disk all the way down,
It would not be right.
why not? Be more specific.
Because you find the area around it.
Very, very close. Not area, but volume. Which volume do I want? Do I want the volume of this bundt cake? Do I want the volume of the inner core?
No, you want
Yeah, the bundt. Sorry, that's a stupid metaphor, but it's the outside thingy is the volume I want. I do not want the core of the inside volume. That's what the discs would give you. The discs would fill in the inside. I want the outside. The only way to get the outside is to do shells. If you do all the shells, that should do it. So, Jana, take over. What is the volume of a shell?
2 pi RHT.
Good. In this particular case, it's 2 pi something something something. Tell me what they are.
The radius would be x.
Correct. And now we can do that with good conscience because it's going straight from 0.
Height would be y.
Height is y?
And the thickness would be dx.
dx. What needs to be fixed?
So y.
Yeah. What is y really?
Radical x.
It used to be.
Oh, sorry. Radical x minus 2.
Correct. So it should look like this. The volume of a shell, 2 pi x, radical x minus 2, dx. Question. Can I distribute that x into the radical? Can I do radical x squared minus 2x? Heck no. You only distribute over parentheses. Radicals, not so much. Leave it as is. This, I would say, trot your calculator out. Let's see what we get. Can somebody set this thing up for total volume? Pete,
So it would be,
how do you get the total volume?
you need to do the integral.
Yeah, integral.
So you put 2 pi in the front.
2 pi in the front is a good idea.
And then it goes from, y goes from,
Are we doing x's or y's?
oh, no, we're doing x's.
X's, good.
So it goes from 2 to 6.
2 to 6, correct. That's the new boundaries. It used to go from 0 to 4. Now it's 2 to 6 after we moved it. And I would just do x radical x minus 2 dx. Grab your calculators. Let's try it. Be careful. When you're doing a radical, sometimes these things will give you decimal answers. In which case, check the instructions on the test. And it'll say, can you, by the way, I have 10 more minutes. Can we actually, you got 10 more minutes, gentlemen. We're on the 9 o'clock schedule. You need to be first period. Hold the 2 pi off. Math 9. X radical x minus 2. Parentheses, comma, x, comma, 2, comma 6. Tell me what you get. You should actually get something nice. Well, here's what I got, depending on your point of view. I got 2 pi times 23.46666709. Okay, math people, translate that. What just happened?
352.
What's that?
352 over 15. It's calculator.
How do you get that?
You simplify it because calculator error. So.
You see this here? Calculator error. Once you have this many decimal places that are in a pattern, when you're doing something hard, number crunching, like an integral, if you have something at the very end that's garbage, throw it away. Make sure you know this. Michael, we covered this, I think, when you were gone. How do you make the calculator think that there are 6s going forever?
I think you should.
Okay.
Just type like 5 in there.
You're right. 13 at least. Yeah, I think 12 or 13. I haven't actually counted them, but 13 definitely works. So what I would do is take like hit clear, and do 23.4, and then type 13 sixes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hit enter and convert to fraction.
Mr. Gottlieb.
Oh, no problem.
Can I, now that I interrupted, can I rudely cut all the way
Oh,
through?
yeah, go for it. Yeah.
Sorry, don't mind me
You're-
just cutting in front of them.
No worries.
Mr. Gottlieb.
My bill will be in the mail. There, got
Is it
it?
okay if that's what, like 17 sixes?
Oh, yeah, more than 13 is fine. Yeah, anything beyond that is fine. This is 2 pi
Is it okay if I put
times,
Yeah, because he like counts to 13. I'm like
352 over 15. If you're in doubt, just do a slew of sixes. You can always do more. Just don't do less. By the way, if you only do like 7 or 8 sixes, it may not work. It may not be enough. Okay, math people. Ahem. Tune in. Simplify. Yeah, that's awesome.
I'll try again.
What's 352 times 2? Oh, math people.
704.
704. So what is it? 704 pi over. Write that down. That's your answer. Okay, don't get too distracted by the multiple sixes, okay? Not the point. When you get to the test and the only thing you remember is how to type 100,000 sixes, it won't end well for you. Make sure you can get that as an answer. Okay? Questions? That should be enough for problems 5 and 7 and 8 rather. I am actually going to give you a little bit of time tomorrow in class to work on this, like 20 minutes. Don't rely completely on it. Do some work on your own. But I'll give you 20 more minutes to ask questions of me, your classmates, et cetera, et cetera. Question?
Say the axis is the y-axis has changed.
Yes.
Would that be to change the output?
Correct.
Okay.
Right. This would be like radical x with a plus 2 on the outside.
Yeah.
And then this would stay the same, this would stay the same, this would be y equals 2.
So if you switch all the x's and y's, do you switch the axes too?
Yes.
Okay.
And like if I switched all the x's, I didn't have to on this one. I need a little more quiet than this. The question was, what if you have one of those problems where you want to swap the x's and y's? This is not one of them because it was easy to graph, but if I had like x equals radical y, which is a little awkward, you can switch all the letters, but this would have switched to around the x as y equals -2. And then you'd have to move that. You'd have to move everything up 2 spaces. Make sense? Okay. Got about 5 minutes. You're welcome to pound away at those. Call me over if you get stuck. Otherwise, good luck. And we'll send you on your way in about 4 minutes. And for those of you watching at home, thank you for your attention. God bless your recovery, and see y'all later.